Alright, we did experiment number 1, which is about fill 2 containers of 1 liter by 2 different distance with a faucet.
Okay, so for this experiment we needed to know the diameter, and with that the area, the time of the 2 faucets, the height, the 2 velocities, the 2 expands, and the density of the water, and of course the gravity. Okay, so with that we were able to know the difference of pressure that was minus 10.585.
And all this was with the Bernoulli's formula.
The materials are 1 string of 3 millimeters, 50 centimeters of transparent hose, 1 string of 20 millimeters, and also 1 object with a mass of 50 grams. 2 strings, one with a capacity of 20 millimeters and the other one of 3 millimeters, are connected by a hose of 50 centimeters. We put soap inside the hose, and the objective of this experiment is to know the force on the plunger by applying the fluid of 500 grams on the 3 millimeters string.
To solve this, we have to follow Pascal's formula that tells us that in order to obtain the second force, we have to know the first force and multiply it by the division of the first and the second area of the 2 syringes. To know our first force, we have to multiply mass times gravity, and our mass is 500 grams. But because this is the mass of the flour that's already being pulled by gravity to Earth, we don't have to multiply it by gravity, so we just convert these 500 grams into newtons. That will give us 0.5 newtons, and that's the value of our first force. Now we have to calculate the first area, that is pi times radius square, and the radius of our first syringe is 0.006, 0.00452. Now we have to do the same with the second syringe, and the diameter of the second syringe is 0.024 meters, and the radius is 0.012. So if we multiply it by pi, it will give us 0.0113. Now we know that our force 1 is 0.5, and that our first area is 0.00452, and our second area is 0.0013, and our result is 2. The value of our second force is 2. This means that the force applied in the plunger of the 3 millimeter syringe is 2 newtons.
So we're gonna speak about the Archimedes principle and its experiment, and the things you need are an apple, a weight, something to hold the apple up, 2 cups, and water. So firstly, you're gonna measure the apple and the cups without the water in it, and then you're gonna write those down. After that, you're gonna put one of the cups and introduce 600 milliliters of water into it. After that, you will introduce the apple into it and see how the volume of the water goes up thanks to the mass being introduced into it. Secondly, you're gonna put the empty cup of water under the full cup of water. Tilt the first cup, the one with water, a little, making sure not to spill or drop any, and then you're gonna introduce the apple. You will be able to watch how the water starts spilling into the second empty cup thanks to the apple getting the volume up.
The Archimedes principle states that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially submerged, is equal to the weight of the fluid that the body displaces and acts in the upward direction at the center of mass of the displaced fluid. Archimedes' principle is a law of physics fundamental to fluid mechanics. It was formulated by Archimedes of Syracuse.
We come to the conclusion that physics are very important, knowing why things are done and their purpose. Also, physics has contributed to the development and well-being of man, because thanks to his study and research, it has been possible to find in many cases a clear and useful explanation to the phenomena that arise in our daily life.